Hey guys, so I thought I'd give you a little video about the different initial conditions and how that works and how you can solve for your constants. So what I've written down here, I've written down a little picture of a mass on a spring, frictionless surface. We're setting the equilibrium point at x equals 0. Here's the differential equation with omega. And here's the solution that I'm going to choose to use. Remember, there's several forms, but I'm going to use this one with the cosine with a constant out in front and a delta. And then the derivative I've also taken here, which we're going to need for our initial conditions, when minus sign out here for taking the derivative. Okay, so let's start. We'll start with one that's a very common one. So we'll start at x equals 0, and we'll bring it out to 0.03 meters. And we'll start it off with no velocity. So at time equals 0, we have no velocity. And this is when you pull it out to 0.03 meters and just let it go. Okay. All right, let's do it. Let's figure out the constants given these initial conditions. So I have two equations here. So here's the first one. I'm going to say x at 0 is going to be a cosine of del because omega t is 0. And that has to be 0.03 meters. All right. Well, it's got two unknowns, so I'm not going to do anything with that yet. I'm going to do the next one. So I'm using my x dot. And so that's going to be x dot at 0 is minus a omega sine of del, and that has to be 0. All right. Obviously, in this case, the minus sign doesn't really matter here, right? Because it gets canceled out, or you can just get rid of it. And you don't really want a to be 0 because then it'd be no motion, right? So omega already is not 0. So the only thing this tells you, well, it's a lot actually. It tells you that the sine of delta has got to be 0. Okay, so when is the sine 0? It's when delta is, 0, pi plus or minus, pi plus or minus 2 pi, etc., right? But we're going to take the simplest one, which is del equals 0, and we're going to say, all right, excuse me, del equals 0. So I got one of my constants, and now I'm going to go back over here and put del equals 0 in here, and of course cosine of 0 is just 1, and I get my other constant, a equals 0.03 meters. Now, you're probably not surprised that the amplitude is 0.03 meters because we pulled the block out to 0.03 meters and let it go with 0 velocity, right? Okay, so now we can write down our full solution here. X of t is 0.03 meters times the cosine of omega t, and that's it, right? There's no del now, it's 0. All right, so what does it look like? Well, let's write omega t here and x here in meters. And so we'll start it out here at 0.03, right? And then we're just going to draw a cosine wave. Badly, I realize that. Yes, very badly. Okay. And points on the graph here. This is at where is it? Where's the cosine 0? It's at pi over 2. So this is omega t equal pi over 2, etc. Over here, this is omega t equal pi, and on and on. Okay. But you can see that the cosine is very, very good for this without any phase shift, right? There's no delta because it starts off at this point, 0.03 meters, right? Okay. All right, and notice that it also starts the velocity, the slope at this point, right, is 0, right? There you go, yeah? All right, so that's the first initial condition. Let me get rid of it, and no, don't want you to get rid of it. Oh, it looks like I messed that up, so let me just do some erasing real quick. Hopefully it's not too bad. It'll take a second. Yeah, I meant to get a new layer, and I didn't do it. Okay. Let's just get rid of everything. All this stuff off. All right. Okay. Back to the pen. And now I'm going to get a new layer so I don't mess anything up. Okay. All right. So now I'm going to do another initial condition, and I'm going to have the x at 0 be 0. Okay. So at time equals 0, it's right here, the box, the mass. And then at x The velocity, however, at 0 is going to be non-zero. It's going to be 3 meters per second. So what that means is that we're catching the box at t equals 0 when it's going this direction. So here's my positive x direction. Going this direction right here at t equals 0 is where we're setting our time equals 0. Okay, so let's find our a and delta. Okay, so the first one, x at 0 is equal to a cosine delta, and that's got to be 0. And then over here we have minus a omega sine of delta, and that's going to be 3 meters per second. Okay, all right, so let's leave this one alone for a second, and let's look over here. We have that the cosine of delta has to be 0 because a is not going to be 0. Now, in this case, you're going to see, well, there's nothing up here in our initial conditions that tells us what the amplitude is, but a, because of this form up here, is always the amplitude, right? So whatever a ends up being, in this particular case, you can't just read it off of the initial conditions, okay? But whatever it is, it's going to be the amplitude. So I'm not going to want that to be 0, right? Okay, so cosine, that means the cosine of del has to be 0. Okay, now, when is the cosine 0? Well, it's at, del equal plus or minus pi over 2, dot, 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 right? 3 pi over 2, etc., etc. I'm just going to choose the first one, but I do have to make a decision about sine. Let me just figure that out. Okay, let's look up here. Let's say that the sine, we chose the negative pi over 2. So let's say we chose delta equal minus pi over 2. Okay, then I would have sine of negative pi over 2, right? It would be minus sine pi over 2, which is just minus 1. Minus 1, okay? And look how that would work here, because the sine of minus pi over 2, right, would give me a minus 1, which would cancel this, and I would indeed get 3 meters per second, because it needs to be 3 meters per second, not negative 3 meters per second, right? That's not what this says. It doesn't say negative 3 meters per second. It says 3. So you have to choose the right phase angle, because notice if I chose delta equal pi over 2, delta equal pi over 2, then sine of pi over 2 would just be 1, and I'd have a negative sign up here, right? And that, because let's just think about it. I'm going to keep going here. So I'm going to have minus a omega equals 3. Well, now I have a problem, because a is not negative, right? A is always defined as a positive thing. That's just the way it is, right? And then omega is certainly not negative. Okay, so this would not be good. All right, so we're going to choose del to be the negative pi over 2. Now, what does that tell us about our solution? X of t. Now we know, oh, well, sorry, we didn't even solve for a yet, did we? So let's do that. So right here, right, so now I'm going to put this in. I'm going to get a negative 1 here. So I get a omega is equal to 3 meters per second. Therefore, a is 3 meters per second over omega. Notice how the units work out. This is in rads per second. Remember, radians aren't a real unit. So the seconds cancel and you get meters, which you should. Okay, so I can write down now my solution is 3 meters per second over omega, and then the cosine of omega t minus pi over 2. Now you might remember here that cosine of something minus pi over 2 is just the sine of that something. Okay, we might go through that in more detail. I think we will. Let's do that. So right here, let's just take this cosine omega t, and I'm going to say plus or minus pi over 2, because we're going to need both of them in a second. Right now we don't. We just need the minus one, but we might as well do them both. So if you remember your trig identities, this is cosine omega, cosine pi over 2, and then the sign switch, minus plus, sine of sine of omega t, and then sine of pi over 2. All right, so this cosine of pi over 2, of course, is 0, so that's out of there. This is 1. So this just becomes minus plus sine omega t. So in this case, right, this is the minus sign, so it gets the plus sign on the sign. So this is really 3 meters per second over omega sine of omega t. And hopefully that makes sense, because let's look at what it looks like. Again, omega t, x in meters. All right, so whatever, so this is a sine curve, right? And it has to go like this, right? Starting at 0, that's what sines look like, sort of, right? Bad drawing not included. And so the amplitude is up here, and we know what that value is, right? This value of the amplitude is 3 meters per second over omega, and whatever our spring constant mass are, which we never said. But notice here, it starts off at x equals 0, which is what we want. It also has a positive slope, so positive velocity, right? Which is exactly what we said it had to have at x equals 0. Positive velocity. Okay, let's kill that layer and get a new one. All right, let's do another example. And it's going to be sort of a simple example because we kind of did a lot of work already. Let's do when x of 0 equals 0, and x dot of 0 is equal to a negative velocity. Okay, again, here we are. You're taking a snapshot at t equals 0. The box is moving this way, right, towards the minus. So it's got a negative velocity. Let's get a and delta in that case. All right, so x of 0 is a cosine of delta, and that has to equal 0. We already know what that's going to give you. It's going to give you delta is plus or minus pi over 2. This one is x dot of 0 is minus a omega sine of delta. And now we have to decide on the sign of delta, S-I-G-N of delta, right? So if delta is positive pi over 2, right, then we will get a negative sign here, because we already discussed that a is not negative, neither is omega, and we'll get our negative velocity, because this whole thing has to be minus 3 meters per second. So let's set delta is equal to positive pi over 2, okay? So this gives me minus a omega is, and the sine of that is 1, sine of pi over 2 is 1, is equal to minus 3 meters per second, so that all works out great. And again, we get a is 3 meters per second over omega. Okay, and so what's our solution again? X of t is equal to a, oh, I'm not even thinking autopilot, okay. All right, so 3 meters per second over omega, and then cosine of omega t plus pi over 2. Okay, now remember from the previous page there, our previous initial condition, we had our cosine of omega t plus or minus pi over 2 was equals minus plus sine omega t, right? Okay, so because it's a plus, I can write down this as minus 3 meters per second over omega sine about that, omega t. Okay, so notice it's negative, right? So let's take a look. So here, right, we're starting off down here. I'm sorry, we're we are starting off here because it's 0, right? So this is x in meters again, and omega t on the t-axis. So we're starting off here again. It's going to look like a sine, but it's going to be flipped because it's negative, right? So it's going to look, we're going to start going down and then come up and down and then come up again. The amplitude is simply 3 meters per second over omega. But notice here that this is x equals 0, which was what we wanted. But notice that the slope is negative here, right? We need a negative slope, right, to match our velocity, initial velocity. Okay, let's do one more. I'm not going to fully do this next example because it's just an illustrative, and you know, all of the ones that we've done so far, the 3 that we've done, we've had either x of 0 be 0 or x dot be 0 at t equals 0. And that is not necessarily the only thing you could have, obviously. You could have both of them be non-zero. So let's just look at what that looks like. Let me get another layer. Okay. Again, I'm not going to solve the whole thing. All right. So, so let's look at the initial condition where we have x at 0 equals something 0.02 meters, and x dot at 0 be our familiar 3 meters per second. So what is this situation? It's where the block is out here at 0.02 meters and moving that direction. Okay, let's just apply our stuff. So x at 0 is a cosine of delta, and that has to be 0.02 meters. Here we have x dot at 0 is equal to minus a omega sine of delta, and that has to be equal to 3 meters per second. Now, it's a little, you know, not as easy, but you have 2 equations, 1, 2, let's see, 1, 2, for 2 unknowns, a and delta. So, you know, what would I do? I would start with just dividing one equation by the other. So I would take this one and divide it by this one. So I'm going to have minus a omega sine delta over a cosine delta, and that's going to be 3 meters per second over 0.02 meters. And I can cancel out my a. And on this side, I get omega times the tangent of delta is equal to 3 over 0.02. I'm not even going to calculate that. And then the units are 1 over seconds. Okay. And obviously, you can solve for delta, which is the arctangent. And I lost my minus sign. There we go. Arctangent of negative 3 over 0.02, and then over omega, so 1 over omega. And I'm just, the 1 over omega cancels that second, so I'm just not even going to bother putting the seconds in there. And so you could do this, and then of course, what would you do? You come back and put that delta in here and then solve for a. All right, much easier in the case where you have, you know, one of these things 0, either x or x dot. Okay, so that's how this works. It's pretty simple in the sense that you just end up with 2 equations and 2 unknowns, and sometimes that's easier than other times. And notice that what I would encourage you to do is, you know, I picked this cosine, right? Pick the sine one. See what happens with these initial conditions that we just went through. Okay, start with the sine instead of the cosine. See, do you get anything different? Well, what happens? So that's what I would do. Okay, I think that's it.